grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Please WhatsApp us on this number 079 578 2908. 079 5782908. Now today we're going to look at paper 2 revision. Now the topics that are on paper 2 will be the following. The first one that we're going to be working on is the analytical geometry, which is quite an easy topic. The 25 marks, we're just targeting a minimum there of about 15 marks, of which you'll see how we get these marks. The next topic that we're going to look at is the trigonometry. The second topic will be the trigonometry, and this is the order of the paper on Monday. The paper on Monday, the first part of the questions will be the analytical geometry. The second part of the questions, which is from question 3, will be your trigonometry up to question 6, and from there you have your Euclidean geometry from questions 7, 8, and 9, and you have your next one, which is going to be your circles, angles, and angular movement, which is your question 10, and question 11 will be on measurement. So the order of the question remains like that. So you go into your examination, the first part of the question, you know it's analytical geometry, and I'm going to do it in that particular sequence. Now, before we go to the papers, you need to go to your information sheet, which we call a formula sheet. Now, the formula sheet has got formulae that you are supposed to use for paper 2. I'm not saying don't use other formula that are in paper that are in that formula sheet, but please be aware that there are formula that can work, that must also work in paper 2. Now, I've done this so that then you go to your formula sheet and check which formula is for what. Look at the first formula. The first formula there is the distance formula. The distance formula is denoted by the D there, and it is written like that in the formula sheet. So in other words, you have to adapt it to your question there. So the distance formula, remember it's x2 minus x1 squared plus y2 minus y1 all squared. So please go and check that formula sheet and check and write down what that formula is as I'm doing this with you now. Now the next one is the midpoint formula, which has got an M there, capital letter M, and it is a plus. Please copy it correctly from your formula sheet. The next one there is a gradient formula with a small letter m that denotes the gradient. So it's y2 minus y1 over x2 minus x1. Please do not swap this around because that makes the formula incorrect. The next one is the inclination, where we're going to get an angle. We're going to use that formula to get an angle that lies between, you know, where you have the angles that lie between the x-axis and the straight line. So that those types of angles, we are going to use that formula. The next one is an ellipse. So that is the equation of an ellipse. It is also there in your formula sheet. This is one set of formula, the group of formula that we're going to use for analytical geometry. If I go on to the trigonometry, the formula that we're going to use for trigonometry, you'll see there we have the sine rule. This one we call it a sine rule. So the sine rule is used when I have two sides and a given angle, or I've got one side and a given and two given angles. So if I've got this side and that side given, and the angle is given, I can be able to get the other angle. If I'm given a side, an angle, and an angle, I can be able to get the side. The cosine rule is also very useful It's also used when I've got three sides given and I need an angle, or I've got two sides given and this angle here must be opposite that side. So that's when I use the cosine rule. Now the area rule, it's used where we have a triangle which does not have a right angle triangle. So in other words, I'll use this side, that side, and the included angle. Okay, so I can use this side and that side, and then this side and that side, and the included angle here. So please know those rules. The last group there is the identities. Sine squared theta plus cos squared theta. Remember, there must be an angle here. Sine squared theta plus cos squared theta, it's equals to 1. We call it a famous 1. The other one is 1 plus tan squared theta equals to sec squared theta. The last one is cot squared theta plus 1 is equals to cosec squared of theta. So remember, this identities, they can be asked in an exam, but they won't ask them as they are. They might take this one to the other side, or take this one to the other side, or they can take this one to this side, and then from there they ask you, what is 1 minus cos squared theta? So you must know that that one will be sine squared of theta. So that is how it can be asked. Okay, now the information sheet on the circles, angles, and angular movement. Remember, these formula are there in the formula sheet. You don't have to go and memorize them. You'll get them in an exam. So the next one there, it's where we have the formula for changing radians into degrees and degrees into radians. That is the formula. This sign is called an omega. It's a sign for angular velocity. What I like about this formula sheet, this part of the formula, is that everything is written, and the question will come in this order that says calculate the angular velocity. So you just come here and write down the formula, and that formula you'll have a mark. If this is a circumferential velocity, you write down the formula. That formula you've got a mark for it, and it's written there. What is D? D stands for the diameter. The N stands for the rotational frequency. So in other words, if I'm asked to calculate the rotational frequency, I come to this formula. I know I've got an N, so D and V must be given. Right. Then other formula there is the formula for the arc length. I mean, the arc length, yes. So now you'll see where the R is given as the radius. This is the central angle. So in other words, this is where you get a figure like that. And then you have an angle that is given. This is your arc length. Then you have an R, which is the radius in this case. So the radius will be given, the angle will be given, but you must change the angle to radians if it's given as degrees. Right. The last two formulae there, same thing. This is the area of the sector. In other words, if I've got something like this, then I have that. Then from there, I need the area of this whole part there. So I can either use the formula when I'm given the S, or I'm given the R and the R, or I'm given the angle. So you can see I'm given so many things here. So if I'm given the arc length and the radius, then I can use that formula. If I'm given the angle and the radius, I can use that formula. So you must first read the question, underline what is given, then choose the correct formula. Please don't write it like this, okay? Because these are two formulae there. Okay, so you're told also what is what is R, what is S, what is theta. All right, so it's a central angle. So central angle, the angle that is at the center there. The last formula there is for finding it's either the diameter of the circle, or we can get the height of the segment, or we can get the length of the chord. So you'll check what the question wants here, and we'll have an example to do on this type of question, on this formula. All right, now in measurements, so where we find the area, there are two formulae there. So that formula there, you can use that formula. and you are told that M1 and M2 and M3 and M4 up to M to the Mn, you use that for all of them. So in other words, M1 they will be the same as that. M2 will be O2 plus O3 divided by 2. M3 will be M2 plus, O2 plus O3 divided by 2, just like that. Or you can use this one, where you use the first ordinate plus the last ordinate, and then from there you divide that by 2. The mistakes that we always do is that one. That one is the one before the last one. So in other words, if I've got ordinates here, and here is my last ordinate, this one, it's this one there, before the last ordinate. Okay, so please be careful when you're writing this formula and then when you're substituting. So the formula are there, so you just need to write down the formula. You'll have 1 mark for the formula, but you must write it correctly. So sometimes if we've got 6 ordinates, then you carry on, you write 3 of them, and then that formula is not correct. It must be all ordinates written correctly. Right, we'll show you when we do the examples. Now, this is your key activities to achieve 30% in technical maths, but we are not looking at the 30%. 30% is the minimum of our subject, but we are not looking at getting the 30%. We are looking at getting up to 50%. 50%, that is our target, getting there. Now, and obviously the PET we're targeting at 80%. I hope every school has already done with the PET. Now, we are going to look at how we can get these marks. We're looking at 50 plus marks in our paper 2. So if you look at this, in analytical geometry, which is 25 marks, we are targeting up to 20 marks. In other words, when I'm having the question paper that I'm working with this weekend for my practice, I must be able to target up to 20 marks in analytical geometry. Then I'll be on the right track. In trigonometry, out of 50 marks, we are targeting about 12 marks, and really 12 marks. We can get up to 20 marks out of this trigonometry. We'll show you how when I do the activities. Euclidean geometry, it's 40, but we are only targeting 10, and I'll show you how we're going to get the 10. In mensuration and circles, angles, and angular movement, it's 35 marks in the paper, plus minus. We are only targeting 11. So if you calculate all these marks there, it's up to 53 marks. 53 marks. But we are really not targeting the 53 marks. We are just saying this is the minimum mark that you must get. But we are targeting all the marks. But for now, when you practice, make sure that you cannot get anything that is less than 53. Your 53 will be your maximum mark. Your minimum mark that you must get. Your maximum is obviously 150 marks. Right, now let's look at the activities in analytical geometry, where we said we are targeting about 20 marks, of which we can get that. The diagram below, not drawn to scale, so we can say this line here, it's parallel to that line because they're not drawn to scale. Represent the picture of the roof above. There was supposed to be a roof there. There's a roof that I just omitted there. The points are given there, and these points are the vertices of a quadrilateral. So I'm told that this is a quadrilateral, ABCD. Now the first question, E is the midpoint. I'm told this is the midpoint. Yes. If they ask me a question on the midpoint, I already have a formula. Theta is an angle of inclination. There's an angle of inclination. Can you see it is between the x-axis and a straight line? Here's my straight line. Here's my x-axis. So that's the angle that is formed there. So I already know the formula that I must go to. So let's go to the first question. The length of CD, which is 3 marks in it. How do I get the length of CD? So the length of CD, where is CD? Here is my CD. I have my coordinates there of CD. So with my coordinates of CD, how do I get that? How do I get the length? Remember, length is the same as distance, so there's no difference between these two. So that's distance, right? I go to my formula sheet and then I look for the formula for distance. So the length of CD, it's going to be the square root of. So I'm going to have my x1, which is going to be, or x2, which is going to be 4 minus 2. And this is squared. So I'm saying 4 minus 2. Then I'll say plus, I come with a y. So the y is a minus 3 minus 3. So the whole thing is squared. So what do I get here? So from here, I can put everything there in my calculator, and my calculator will do all the work. If I'm not going to do it with a calculator, then I've got 4 plus 2, which is going to be 6 squared. It's 36 plus minus 3 plus 3 is 0. 0 squared is 0. So I'll have the square root of 36, and the square root of 36 is 6. So CD, the length of CD will be 6 units. That is the length of CD. Okay, so you have a formula. Write down the formula, you'll get a mark for the formula, you'll get mark for the substitution, you'll get mark for the final answer. Okay, so that's quite straightforward and easy. Right, 1.2, still on the same question. The coordinates of E. Now I can see coordinates of E. That's what I like. Because I know the formula. And the formula for the coordinates of E, remember, is the midpoint. So meaning that E, the midpoint, will be my x1 plus x2. Remember, I start with the x value, then I come with the y. The x1 plus x2, the x is there, my x is there. So I'll start with the x. So it will be minus 3, plus minus, so it will be minus 2 all over 2. And then will be a 5 minus a 3 all over a 2. So my coordinate of E will be negative 5 over 2, which is negative 2.5. And 5 minus 3 is 2. 2 divided by 2 is 1. Then I can check if I'm correct here. If D is there, it's negative 2. This could be 2.5. So I'm fine with the x. With the y value, that value there can be 1. So I'm okay with it. So I can see, even with my answers, I can be able to see whether that point will be relevant to the sketch that is given to me. Okay, gradient of BC, I love this. I've got the gradient formula. So what is the gradient formula? It's a small letter E, M. So what is the gradient of BC? So where is BC? Here is BC. Okay, so with the gradient of BC, what do? Is the y2 over the y1, y2 minus y1 divided by x2 minus x1. So let's go there. So I'll start with the y. So my y is 5. So it's 5 minus minus. So it's 5 minus 3 divided by, I'm done with the x, then the y, it's 3 minus 4. Remember, it's the gradient of BC. So my gradient of BC will be 5 plus 3, which is 8. And 8 divided by negative 1, my answer will be a negative 8. So the gradient of this line here is a negative 8. All right. Now, the next question, it's still on the same question. Can you see? Now we are having these questions that are based on the sketch. I already know what is the gradient of that. Remember, I can use the answers that I got previously to do the next question. Remember now, I know what is the gradient of that line. I know the gradient of that line is negative 8. Now, they're asking me a question to calculate the size of theta, which is that angle. And I know the formula. Can you see? I already wrote 4 formula. So this is the 4th formula. The tan of an angle equals to the gradient. Can you see? Already, even if I did not substitute, I already have 4 marks only by writing the correct formula. So now, how do I get the theta? So I know that the gradient of this line, because it must be the line and the x-axis, so it will be -8. Now the tangent of theta is -8. So if I go to my calculator to get the value of theta, I first disregard the negative. I'll use it. So I'll say shift tan of 8, and that gives me 82.87 degrees. And I call this a reference angle. Why? It is because that angle that I'm looking at here, it's more than 90 degrees if I look at it like this. So it's an obtuse angle. So it means that the 82 cannot be correct. So which means I know that this one, if I need this angle, it falls, if it's 90 degrees there, it falls in the second quadrant. Then I use the reduction formula, 180 degrees minus 82.87. Then the angle that I'm going to get there will be 97.13, which is an obtuse angle. Okay, and this question, it's always a problem because we are getting solutions where learners are using the negative and they get a negative angle. And in this case, we want it to be a positive angle. So we rather disregard the negative when we put it in a calculator, and then from there we can then do it by using 180 minor. But I know there are some learners who somehow get it right by getting the negative angle, and that negative angle that they get, they add it to 180 degrees, and that they get the correct answer. That is also acceptable. You must just check how the teacher has taught you. If you're not sure about that, please go to disregard the negative and then subtract the angle from 180 degrees. Okay, right. Now, the last question on this activity is determining the line parallel. Now, these are keywords. Parallel, what does it mean to us? It says it must be parallel to BC, to line BC, right? But this line must pass through -3 and 5. So this line must be parallel. We don't know how it's going to go, but it must be parallel to that one. First of all, keyword parallel. What do you know about parallel and gradient? The gradient of parallel lines are equal. So I know the gradient of this line, meaning that I also know the gradient of that line. You see? So already on my equation of the line, y equals to y1 equals to the gradient m, I already know it's -8, x minus x1. All right, I already know the gradient. Now, so I'll get a mark for the gradient because I know it. The next step will be to substitute the point here with an x, that point there. So my y1 will be 5. My x1 will be a -3. Right, so I work it out. Y will be equals to -8x. I've already multiplied this one in. Then the negative times negative is a positive. So I'll have a positive times a negative will give me a negative. So I'll have a -8 times 3, it's 24. But then I must add a 5 from that side. Okay. So my y value is going to be -8x. Negative that will be -19. So my y value will be, so my equation will be y equals to -8x minus 19. If I extend this line there and I extend that line there, I can see that my y value will be around, the y-intercept will be minus 19, then I know I'm fine with it. Okay, but can you see that these answers, you must connect them to the sketch, look at the sketch and see if your answers make sense. Okay, so if they don't make sense, check maybe there was a sign of the mistake of a sign there and there, or the mistake of substituting there and there, and then so that you get full marks on this question. All right. Now, question activity 2. In this diagram below, O is the center of the circle. You are given the point P as minus 4 and 3. There's a tangent which is WS there. And now the first question says you must determine the equation of the circle. It states there, show all calculations. You see questions where they say show all calculations, please do so. Because when you don't show all calculations and you just give us the answer, you will lose marks. So let's show all calculations in this one. So what are we going to have? Equation of the circle, we know. First of all, we must write down the equation of the circle. Then I know that circle passes through the point 4 and 3. Then I substitute the value of x by 4, the value of y by 3. Then I need the r squared. So my r squared is going to be 16 plus 9, which is going to be 25. Most of you guys, you stop there and then you did not give us what the question wants. The question wants the equation of the circle. So you must come there and say, therefore, the equation of the circle will be equals to x squared plus y squared equals to 25. That you have answered the question. So if you leave it here, we are not going to give you full marks. Okay, so please make sure that you finish that question. Right, the next question, still on the same question there, the gradient of OP. So in other words, I need the gradient of OP, and I'm going to show you a very easy way of doing that. That is why it's 1 mark. We know this point here, it's 0, 0. Then that point there, it's 0.3. Then you work it out. You know, we're wasting time there. If I see that the point there, the point that is given there, it's 4 and 3. Let me show you how you do it. Now the gradient of that line will be 0 minus 3 and 0 minus 4. So what you need to do, just to write down the gradient of OP, you're going to take the 3, put it on top, the 4, put it at the bottom, and that will be the gradient of OP. So you take the 3, the y value, and the x value, as long as your center is 0, 0. You see? So you are losing marks, easy marks. So your point is given, the gradient is already given. Is the y value over the x value. So it's the change in y over the change in x. So that's a 1 mark. The equation of WS. So WS is your tangent. What do you know about the radius and the tangent in a circle? The radius, that gradient is 3 over 4, meaning that the equation of the tangent is going to be, so the gradient of the tangent is going to be, you swap these values now. So I swap those values and I change the sign. So it will be negative 4 over 3. Okay, because the tangent is perpendicular to the radius. Remember, in geometry, we know that. Okay, now we need the equation. Remember, equation, we write this formula for the equation, which is an easy formula to remember. Is the formula that comes from the gradient formula. Right, so now my point is this now. So your y will be minus 3 I mean, sorry, positive 3. My gradient now, I take that one, which is negative 4 over 3, x minus, my x1 is 4, then I write down the equation. So it's negative 4 over 3x times that is positive 16 over 3. I add the 3 from that side. So my y value is going to be negative 4 over 3x plus 3 times 3 is 9 plus 16 is 25 all over 3. Okay, and that's how we get the equation of the line. So there's the equation of this particular line. You see, it's the gradient is negative. So our 0.25 over 3 can be somewhere there, up there. So I think we are fine with this one. Okay. All right. So now this is your questions that come in this section, analytical geometry. So in analytical geometry, we're going to get a circle question. We're going to get this, and the next question is the one that always comes, and we're not getting it right. Now, from today, we must get this question right. On Monday, we must get this question right. So if I've got x squared over 32 plus y squared over 4 equals to 1, they want me to sketch this one. So what I do is I come here on the x-axis. So here's my x-axis. I get the square root of 32. I know the square root of 32 will be a decimal, which is 5,7 to the nearest. So I'll go and get 1, 2, 3, 4, 5, 6. So 5.7 will be somewhere there. I make a mark. I go on the other side. This is negative 5,7. I go on the other side. 1, 2, 3, 4, 5. 5.7 will be somewhere there. I make a mark. Now I go to my y-axis. So on my y-axis, I've got plus minus square root of 4. So square root of 4 is 2. So it's 1, 2. So I'll get a mark here. Get 1, 2. I'll get a mark there. And then from there, I just join that. I'll join this one, and I'll join that, and I'll join that. And I have my sketch. So I'll put my points here, 5.7, I'll put a 2, I'll put a negative 2, I get full 3 marks here. So this is an easy question that everyone must get right. Okay, all the questions are a bit challenging, but this one is the easiest question in paper 2. Right. So please practice it. Right. But check this question. Sometimes the examiners, they write a number there and then they write like 4 squared. And please do not multiply it. You already have the 4, so use the 4. Okay. Right. Don't use the 32 there and the negative 32 there and 32 there. You can either use it as it is, square root of 32, or square root of 32 this side, the negative there. So you can either use it like that. But I cannot put a 4 here because I need a square root. Remember, y it's squared. So we need a square root of that one. So that's, I think, the trick there. Okay. Now, in trigonometry, mostly the first question there, it's all about calculator usage. Now in this one, they say calculate the value of this one. Now the trick here is that this angle that is given there, it's in radians. And this one is in degrees. Then it means I must first change this one from radians to degrees. And then I can be able to use my calculator. Remember, my calculator is in degrees. So I've set it in degrees. So how do I then change 3 pi over 4? So 3 pi over 4, to change it to degrees, remember the formula that I showed you on how to change this. So it will be 180 degrees over pi. So the pi and the pi cancels out. If I use my calculator there, I'll get 135 degrees. So that is my angle. So it means that x now will be 135 degrees. and I've got 72 degrees. So it's now easy for me to go and substitute these values. So I'll have cos of 135 minus 72 degrees. Use a calculator to get this. Go to your calculator and say cos open bracket 135 degrees minus 72, and then the answer that I think I got was 0,45. Okay, right. I like writing it like this because it's not an exact number, it's 0,45. Right, so now this question everyone also must get, because then you're given the values, you have a calculator, you just put this in a calculator and do that. Now, sometimes they give you the reciprocal of that. Please note on this one also. Right. This is a bit of a challenging question, but I think we must first look at this question and make a plan. Right. It's mostly about 5 marks to 6 marks where they say use a sketch and do that. In this case, they didn't ask us to use the sketch, but I would like to use a sketch. Firstly, check this. It's a sec. So now I know sec is 1 over cos alpha. But I know that if I write it as the cos of alpha, what should I do? I must switch these values around. So now I'll have negative square root of 3 over 4. Then I know that I have to work in which quadrants? I have to work in quadrant from 0 to 180, meaning that these two quadrants are not working for me. The first quadrant, the cos is not negative, so this one is also not working. The only quadrant that is left for me is this one, right? So now here's my angle alpha, and now I need to put the values. I know cos is x over r. So my x value is negative root 3. My r is 4. So I need a value of y. So if I use the theorem of Pythagoras, it will be 4 squared minus the square root of this, square root of 3 squared. So it will be 16 minus 3, which is 13, and the square root of 13 will be my. They said without use of a calculator, so I cannot write the square root of 13 as 3 comma something. So I need to write it as the square root of 13. Because if I use the calculator, they will see I'll have written 2,6 or 2, something. So we will see. Now, I have my x, I have my r, I need the tangent of theta. Can you see why it's 3 marks? It is because I first need to get the value of y, because I cannot get tan alpha if I don't have y. So now, tan now is opposite over adjacent, so it will be negative square root of 13 all over square root of 3. I can leave it like that. Okay, so don't use a calculator, please leave it like that. So it's square root of 13, or if I want to be smart, I know that learners who wants to be smart, so they can write it under 1 square root, and they write it like that. That's when you want to be smart. Okay, right. The next part of the question, already I know the tangent. So the tangent is already given, but I just need a square. Oh, that's easy. So I can go square root of 13 all over square root of 3 with a negative. This thing is squared minus. The sign is opposite over hypotenuse, so it will be square root of 13 all over 4 all squared. So my answers will be, from here, use a calculator. No one will see that you have used it, unless if your answers will be in decimal. But I know with our calculators, they are set in such a way that your answer, if it is a fraction, answer, it will leave it as a fraction. Please don't go to a decimal. If we don't have to use a calculator, square root of 13 squared is 13. Square root of 3 squared is 3. Minus square root of 13 is 13. All over 16. My LCM is going to be 48. And then from there, 3 into 48, 16 times 13. And then from there, I subtract the 13. And then if I get all this, then I get 169 all over 48, which is my final answer. Please do not take that answer and put it on a calculator and then have your decimal as your answers. So that one will mark it incorrect. So that's how we do that question. So even if they don't say by using a sketch, draw a sketch, because it gives you a nice picture of what you're going to have at the end. Okay, right. And that question mostly is about 5 marks, 6 marks. Okay. Here's another question that I also want everyone to get it right. It comes every year. So it says, given this, simplify the following. The tangent of 360 degrees minus. So if I have got my cast, 360 minus is in this quadrant where we have cos as positive. So meaning that if it's the tan, it becomes negative tan. That's the 1 mark that we are looking for. No calculator, nothing. Okay, right. So you must know your diagrams. This is 180 degrees minus 180 degrees plus. So here is a tangent positive, sine positive, all positive. Okay, hence simplify this, meaning that already you have an answer for this one. You see? So pi, we know, represent 180 degrees. So which means this one is going to be cot 180 degrees plus theta. So cot 180 plus theta is in the third quadrant. Tangent and cot are friends. So which means that the cot will also be positive. Right. Multiply that. 180 degrees plus falls in the third quadrant. In the third quadrant, the sign will be negative. Okay. You see how we get this one. 360 degrees, you already have it, is negative tangent. Meaning that we are not going to mark it here because you already have it. You have your mark in A. Tan square of theta minus sine square of theta. Now, if you remember, in that we had one in the square identities, we have 1 plus tan theta equals to sec square of theta. You see the trick? I want to show you what. So you must always be very, very careful, especially with the ones with the squares. If I take sec square of theta to this side and 1 to that side, so I'll have tan squared of theta minus sec squared of theta equals to negative 1. Can you see now that whole thing there? Everything there is minus 1. So instead of writing all this, I'll write minus 1. Okay, so be careful when you're dealing with this, because then you'll have issues like this. Okay, so now cot, I know it's going to be my cos theta over sine theta. Sine, it's going to be the negative, and the negative is a positive. So sine, I'll write it as a sine of theta. Tangent, I'll write it as sine of theta divided by cos of theta. Remember, everything there is over negative 1. So this is over 1. So the sine and the sine will cancel out. The cos and the cos will cancel out. The answer that is going to be left there will be 1, will be sine of theta. So divide by negative 1, my answer will be negative sine of theta. Can you see that whole thing there? We have reduced it to that simple answer here. That is why the question was simplify. Okay. All right. This question everyone must also get. Okay. Right. The next one is an identity, which is also very, very, very easy because I can simply get up to how many marks here? 1, 2, 3 out of 5 minimum. Because first of all, when I'm proving identities, I must use one side. So I'm going to use the left hand side. So tangent, I'm going to change it to sine theta over cos theta. This you must know. It's not there in the formula sheet. Please know it. The sine of theta plus cos theta will be the same as cos theta over sine theta. Remember, it's an opposite of tan. Okay. So now I can multiply what is inside the bracket. So I'll have sine of theta times sine theta will be sine squared of theta all over cos of theta, because I'm multiplying this with it, plus cos theta times cos theta, it's cos squared of theta. Now I can see that this one, sorry, it's cos squared of theta, yes. So, but I can see that one of the cos here will cancel with one of the cos. This sign here will cancel with that sign there. So my answer will not have a square. So I'll only have cos of theta. Right. So now if I want to work this one out, this is over 1. Cos times cos, it's cos squared. So it's sine squared plus cos squared all over cos theta. So in other words, cos theta is our LCM there. So it's cos theta into cos theta is 1. 1 times sine squared theta is sine squared theta. 1 into that is cos theta. Cos theta times cos theta is cos squared theta. What do I know about the top one here? It's a famous 1. So in other words, it's going to be 1 over cos theta. What do I know about 1 over cos? It's sec of theta. And this is the same as the right-hand side, which is that answer that I'm looking for. Remember, I'm proving. So I need the left-hand side to be equal to the right-hand side. Okay. Some of us can stop here, and then from there they go to the right-hand side and write sec as 1 over cos. Still fine, because the left-hand side will be equal to the right-hand side. Okay. The last question in trigonometry, which are basic questions that we need to look at. And this 9 marks, it's a giveaway marks. Show you why. First of all, they want the period of the graph of x. You see the period there, we have a 1 here, 1x. So meaning that the period of that graph will be 360 degrees. That's all that you write. Because our complete graph for the cos will be from 0 to 360. That's a complete graph. That's one complete graph. So if I add a 2 there, so my period will be 360 divided by 2. If I have a 3 there, I'll have 360 divided by 3. That will be my period. That is a complete graph. Equation of the asymptote, remember the asymptote is on the tan graph. So my tan graph, the asymptote will be at 90 degrees. Right? My x value for the asymptote will be at 90 degrees. Okay. Write down the range of f. So the range of f. So remember, the range is how high your graph can go and how low your graph can go. So if I've got a -2, so in other words, and I don't have anything added here. So in other words, my range will be from -2 to 2. Then I put a less than sign there. So I put a y value because it's a range. I'll put a less than sign there, less than equals to that. So the range will be from -2 to 2. I know most of you will be writing it in words, like from -2 to 2, but let's learn to write it in this form. Okay, right? Or y is an element of, so that will be -2 included, and also 2 is included. So we must write in correct notation. Okay. Learn your notations. Now the next one is 6 marks, which also it's a bonus. We need to get this question right because we can use our calculators to get the points. You know, the points are given in this case. So I can even the 0 there. I already know that 90 is my asymptote. So I'm going to draw my asymptote there. Then from there, I'm going to get my calculator to draw the graphs. So remember the graphs are y equals to negative 2 tan, 2 cos x. The other one is y equals to tan of x. Right? So, and the graphs must stop here. So what I'll do is, then I've got a negative 1 here and a negative 2. I've got a 1 and a 2. So I take my calculator and substitute the value of x by 0, substitute by 45, substitute by 90, substitute by 135, substitute by 180 degrees. Then you'll have your correct graph. So if I substitute that for the tangent, it will be 1. So my graph will pass at 1. It doesn't touch there. But remember, if it goes up there, it must start on the other side. So it must go there. So it must be up to somewhere there. Right? So it must stop. Okay, so it must stop there. At 180 degrees, I think it's somewhere there. So it must stop there. So now, let's erase that part here. Let me see if I can go and erase there. Okay. But sorry about that. That part there must not be there. So this graph, let me just get my rubber. Then I'll come back after a minute. Okay. Now let's continue. Sorry for the technical glitch there. Let's continue. So now the graph that must be drawn for the tangent, it will be from here down there to there. So disregard that graph that I've cancelled there. So the tan graph will be that graph there. Remember the tan graph is the G graph. Then I need the cos graph. So the cos graph, remember it's a negative graph starting at -2. So it will start at 0 at -2. Then it will pass at 90 degrees, 0. And then from there it goes to 180 degrees. And then it will go there at 180 degrees and it stops. And this is our F graph. So the cos graph, remember, it will only be up to 180 degrees and it stops there, and the tan graph also stops there. So those are the two graphs, and that's 6 marks for you guys. So you must be able to can do it by using a calculator and using the points that has been given to you. If these points are not given, then please make sure that you know that the tan graph will require a 45, and if it's a sine and a cos, then you can either use the 60 or the 90 degrees, and then you can get the two graphs. Okay. Now, getting to Euclidean geometry, which is 40 plus marks. And we said we are only looking for 10 marks. But 10 marks for this one, guys, it's very little. So we must try for more. But 10 will be your minimum that you're looking for. In this case here, there are questions that are given in this order, where you just need to fill in. Question, the first one being, complete the following theorems. So if I look at the first one there, it says, the angle subtended by the diameter. So in other words, if I can just draw a picture there, I've got a circle, I've got a diameter, and I've got an angle which is subtended by the diameter. What do you know about that angle? It's 90 degrees, and that's all that we need. Okay, so you must know the weighting of all those theorems. The exterior angle of a cyclic quad. So if I've got a cyclic quad, for instance, and I know the exterior angle is the angle on the outside, so it's equals to the opposite interior angle. So in other words, that angle is equals to the opposite interior angle. So this angle outside exterior equals to the opposite interior angle. Okay, so that's 1 mark for that. The last one there says there's an angle between the tangent and the chord. So I've got an angle, I've got a tangent, and I've got a chord. So the angle between the tangent and the chord, the point of contact here, will be equal to the angle in the alternate segment. So it's equals to the angle in the alternate segment. Okay, right. So which means that this angle that is formed between the tangent and the chord equals to that angle in the alternate segment. So please know the weighting of all the 9 theorems, in your Euclidean geometry. Right. The next one is a rider. I love riders because they're quite easy. You know, I always do my rider without looking at the questions. But in this one, it says, in this figure, you are already given that PQR as it's a cyclic quad. So you're given that it's a cyclic quad. Already I know. PS is parallel to QR. So PS is parallel to QR. Now QT is a tangent. That line is a tangent, that line is a tangent. Already I know that two tangents drawn from the same point will be equal at the point of contact. So these lines here are equal. Okay, so the information that I read there, it's there on my sketch. Right. But there's another information that is in the sketch, but it is not in there. Okay, now let's check this. This line here, that line there, can you see that line there here? that one. Okay, and that line there, it's equals to this line there. So it's parallel, that other line will be equals to that. So what do you know about this? So I'm just going to make them like this. What do you know about those lines? Equal chords subtending equal angles at a point of contact. So this line here is opposite that angle. This line here is opposite that angle. So meaning that those angles are going to be equal. But let's read the question. Write down, given reason, 6 angles equals to 32. So which means that in this diagram, there are 6 angles that are equals to 32. First, I can see this one and that one are equal. So that one is going to be R1. So I can write down now R1 equals to 32 degrees. The reason there will be the tangent, two tangents drawn from the same point are equal. So it's this angles here will be angles opposite equal tangents. Okay, right. So it's angles opposite equal tangents, right? But because I'm talking about tangents here, and obviously I can just say sides also, because I already know that this side and that side are equal. Is the first one. So the second one, let's check the second one. So this is 32. I know that this is a tangent chord. Can you see? So this angle here will also be 32. So that angle there will be P1. So angle P1, it's equals to 32 degrees. My reason there will be tan chord theorem. Okay, so it's a tan chord theorem because it is the angle between the tangent and the chord. Right. Now the third angle there will be P2. What is the reason for P2 to be 32 degrees? Equal chords subtend equal angles. You see, the chord here and the chord here are equal. They subtend equal angles. So this angle here will be 32. So I'll say equal chords subtends equal angles. Right. So P2 will also be 32 degrees. Now, the next one that I'm going to get is R4. So R4 is this one here. So it's 32 degrees. The reason being tan chord theorem. Can you see the tan chord theorem? So the fourth one will be R4, it's 32 degrees. So the reason there will be tan chord theorem. All right? Now, the next one there will be R2. Now, R2 will be somewhere there. So this is R2. Why is this R2 equals to 32 degrees? It is because this line is parallel to that. So there will be alternating angles. So R2 will also be 32 degrees. Now it will be alternating angles. So the alternating angles, you must write down the lines that are parallel, which are PS, it's parallel to QR. Please write this. It's very, very important for you to write. The sixth angle that is equals to that, it's Q3. So Q3, it's there, so it's 32 degrees. So Q3, it's 32 degrees. The reason there will be the tan chord here. So already I've got 12 marks if I do that question like that. So can you see that 12 marks? Already the 10 that I was looking for, I'm done. I've done it in one question. Okay, so if I get a question like that where I needed to write down the reasons for that, those angles to be equal, the reasons are very, very important. If I struggle with the reasons, then but I know the angles, I can write down the angle, but I'll get 6 out of 12, which is half of 12, which is 50% of what I need there. But please make sure that you know your reasons and then you put the reasons down. The next activity there is, there's a question here. It's also given there that TK is parallel to MN. TKLM is given. Those are the points on the circle. TKLM, which means that that will be a cyclic chord. Okay. So I have a cyclic quad there, T, K, L, M, because all 4 points are on the circle. This line here is parallel to that. I will not have any alternating angles here, please. I will have co-interior angles that I'm going to show you now. K1 is given as 61 and then M1 is given as 39. Calculate with reasons the size of that angle T. So angle T here, so I'm looking for this angle here. So first of all, I can get, for me to get angle T, so I need to get this angle here, which is TMN. So if I get TMN, then I'm fine. I can get that angle. But I can see that this whole angle here plus this angle will give me 180 degrees. The reason being, these two angles are supplementary because they're opposite angles of a cyclic quad. Right, so TMN plus 39 plus 61 will give me 180 degrees. So opposite angles of a cyclic quad. So in other words, so TMN will be equals to, so it will be 180 degrees minus 100. So TMN there will be equals to 80 degrees. So I can write this one now as 80 degrees because I know that. So let's check this. So that will be 100. So 180 minus 100, that will be 80 degrees. So my TMN there will be 80 degrees. So now let's check. 39 and 41. So my T1, because I need my angle T there. So 39 plus that, because that angle here plus that angle there must give me 180 degrees. So I've got a 39, I've got a 61, so I'll have an 80. So that angle there will be 80. Okay, so I'll have that one is 80. So 80 plus 39 plus 61, the whole angle here must give me 180 degrees. I hope you understand it. Now, if that is 80, then this angle here and that angle, so my T angle will be equals to 100 degrees. So that one will be 100 degrees because 80 plus that will give me 180, and the reason will be co-interior angles. Co-interior angles. All right. Now, if that angle is 100 and I need that angle, remember this is a cyclic quad. That is a cyclic quad. So for me to get this angle L1, I must add it to this to give me 180. So that angle there will be 80 degrees. So the reason there will be opposite angles of a cyclic quad are supplementary. So I'll have this angle as supplementary. So therefore this angle is 80. And I know that this angle there will be 61 because they're corresponding angles are equal. So if I check in this triangle here, I'll have 39 plus 61, which is 100. 100 plus 80 will be 180 degrees. So T will be 100 and L1 will be 80 degrees. I hope we get that right. Now, the next question there is also on Euclidean geometry. So when you're doing your Euclidean geometry, make sure that all these angles, they make sense. In a triangle, you cannot get angles that are over 180 degrees or are below 180 degrees. So when you add them together. So it's very important that when you're doing all these questions, then you check in a triangle or you check in a quad. And in a quad, you must know all these angles, they add up to 360 degrees. And that's how you can know that at least this question makes sense. I cannot have two angles in a triangle that are obtuse. So in other words, one of the angle must be obtuse, the other two must be acute, so that I can have 180 degrees. Now, the next activity is on a proportion. So I'm given that this line, it's parallel to that. Nice. I'm given that this is x, this is 2, this is x plus 2, and that is 3. And they're all in centimeters. Now I'm requested to find the value of x, determine the value of x. Now from this, and you must know in Euclidean geometry, we must write down the results. So in this, I can see that if this line is parallel to that in a triangle, therefore the PM over MQ is the same as PS over SR. So I'm going to write that down. PM over MQ is equals to PS over SR. Then I write down the values and that's just solve for x, right? So my PM is going to be x. My MQ is going to be 2. PS is x plus 2. And then my SR will be 3. So I just cross multiply. So I'll have 3x, it's equals to 2 times x is 2x. 2 times 2 is 4. So 3x minus 2x is x. On the other side, I have a 4. So my x will be 4. So which means that that side will be 4. That side will be 4 plus 2, which is 6. And this side is 2, and that side is 3. So can you see the ratio is correct now? 4 over 2 is the same as 6 over 3. So the ratio is correct. Okay. Easy question. And when you look at your questions in the exam papers, if you find triangle where you have this line being parallel to that, then the ratio will be this. It will be like that. So we can have the ratio this over that, or this over that. But on the other side, I must do the same this over that. So I must do the same thing on the ratio. Okay. Euclidean geometry, it's easy. You just need to write down, know your reasons. When you're practicing your reasons in Euclidean geometry, make sure that you practice with a rider. And you don't go and learn all those without a rider in front of you. You must get a rider. Go to your exam guideline. That's where your reasons are. Seconds, angles, and angular movement. Now here, this diagram, it's an electric saw with a larger blade. So there's a blade here with a diameter of 30 centimeters. So the diameter, so in other words, my diameter will be something like that there. So it will be 30 centimeters. Now, it is used to cut a wooden board. The height of the major segment. So in other words, from here, from the top there, from the height of that thing, of the major segment. So in other words, we have a major segment and a minor segment. The height of that major segment, it's 85% the length of the diameter of the blade. So what does this mean? If I can just quickly draw a picture of what I'm talking about here. If I've got this blade here, I've got a blade, so I've got this, it's PM, this is what they're talking about here. We have a diameter, right? And they're saying the diameter, it's 30. In other words, from here to there, it's 30. But now we have the height of the major segment. So here's the major segment here. The height of the major segment is this one. And they say it's 85% of the length of the diameter. Okay. So in other words, what would be the height of the major segment? So which will be 85% of the diameter. That's what we are told. We are told that the height of the major segment is 85% the length of the diameter. So 85% of that means 0.85 multiplied by 30, and that gives us 25.5, right, centimeters. So that will be the height of the major segment. So the major segment, it's 85% of that. So it means that it is smaller, shorter than the diameter. So you can see this one is a diameter, but that one is shorter than the diameter. Okay. Now the next question we are requested to find the exact length of PM. So the PM is the line there. So it's a chord, it's not a diameter. So it's a chord. So if I go to my formula sheet, I'll get a formula which talks of the length of the chord in circles, angles, and angular movement, which is 4h squared minus 4dh plus x squared. Please do not memorize this formula like I'm doing. You must go to your formula sheet, then know how to write down the formula. So I'll then substitute because I know everything. I know the height. My height is 25,5 squared. I know my diameter is 30. I know my height is 25.5. But what I don't know is my chord, length of the chord, which is PM in this case. So I'm going to get x squared, right? So I'm going to get minus. So if I work out this using my calculator, I'm going to get 459 equals to 0. Then I'm going to take the 459 to the side. From there, I get the square root of this. And they need the exact length. In this case, will be 21. I know I got 21.5, 21.4. So the exact length of the length of that will be 21 in this case. Okay. So it's 21.43. I can write this 21.43. Okay. Right. So I'll just approximated that one to 21. The answer there was, I think it's 21, or something. Okay, right. So that question is also a very important question. Just read the question, see what they want, go to the formula sheet, choose the correct formula, and work it out. Okay. Now the next question says, a wheel with a diameter of 300 millimeters rotates. See, there's a diameter, and it's given in millimeters. Rotate at an angular velocity. You see what is given there is an angular velocity. Use the appropriate formula to calculate the circumferential or peripheral velocity in meters per second. Already I can see there's something that I must do there. Which means from millimeters, the 300 millimeters, I must change it to, because it's a diameter, I must change it to meters. So I must then have that as meters. So that's my diameter. Let me also write down the radius. If I need it in radius, so it will be 0.15 meters. So for me to calculate when I'm given the angular velocity, for me to calculate the circumferential velocity, the formula that I must use, it is not there in the formula sheet, you must know it. If I'm given an angular velocity and I needed to calculate the circumferential velocity, this is the formula that I'm going to use. Then omega multiplied by the r. Right. So if I don't know that formula, I know that my omega is 2 pi n. Right. So it's 2 pi n. Right. So now I know that this is my formula for the omega. So it's 2 pi n. So now I can be able to work out that one first. But do I have the number of revolutions? No, I don't have the number of revolutions. So the formula that I can use is this one. So now let's check this. What is the velocity? Not given. What is the omega? The omega is given. It's 40. What is my radius? My radius is 0.15. So I need this velocity. So the velocity will be 6 meters per second. So in other words, I'm writing it in meters per second as I'm told. So the velocity will be in meters per second. Right. The rotational frequency. So in other words, I'm looking for the value of n. But can I get n if I do not have the velocity? Yeah. So now what do? I'm going to say B equals to pi diameter n. because then what am I looking for? I'm looking for n there. Or I can use that formula, omega equals to 2 pi n. Now in this case, I know what the velocity is, pi. My diameter is 0,3. I do not have an n. So if I calculate n will be equals to, if I divide 6 by pi times 0.3, I'll get 6,37. And remember, this one is radians per second because it is rotational. So I mean revolutions per second because it's rotational. Okay, revolutions per second. Right. Now, the last question that I'm going to do now is on the irregular shape. So remember, irregular shape. This question is the last question. It's the last but one question in paper 2. The last question being the measurement. In this question comes every year, and we really need to work on this question and get it right. In this question, it says the irregular shape shown below, it's 3 meters long. There's one vertical side which is 3 meters long, which is divided into 5. They even tell you it's divided into 5 equal parts. The ordinates, these are the ordinates. The ordinates. They say they're given there. They're all given in centimeters. Check this. Write down the length of the equal parts. 3 meters is what is given. So because this is in centimeters, then I must change this from centimeters to meters. So if I check 3 meters and I want to change it to centimeters, what do I do? Then I'm going to multiply that by 100. So I'm going to have 300 centimeters. But then it is divided to 5 parts. So the A value there will be that divided by 5. So my A will be 60 centimeters. Even if I use that, because they did not tell me anything about the meters and the centimeters, about the units. So it's either I can have 3 over 5, or I can have it as 300 over 5, which is 60 centimeters. Because I see the centimeters, so I want to work with centimeters. Okay. Then the next question is obvious, determine the area. Sometimes the area will be given, they want one of the ordinates. In this case, the area is not given, so I need to get this. The area is not given, so I need to come up with a formula. So I'm going to use the formula that use the first and the last. So the first one is 70, the last one is 30. So I'm going to say my A is 16. Then in the bracket, I'm going to have the first one is 17. I'm adding it to a 30. I'm dividing this by 2. That's the only one that I'm going to divide by 2 when I'm using the second formula. Then I'm going to add the 90. I'm going to add the 120 and the 49 and the 80, and I close the bracket. Those two I already used them there, because I think that is the biggest mistake that we do. Then we use it again there. So check that. Now I'm going to multiply out this, and then the answer there becomes 23340. Remember, its area is square centimeters. Now I see in bracket there they said in square meters. So they don't want it in centimeter, they want it in meters. So how am I going to get my final answer? So my final answer will be, remember, for me to get from millimeters, from centimeters to meters. So this is 10, this is 10. So I'm going to meters now. So if I go to meters, I'm going to divide this by 100. But in this case, it's a square, so I need to divide it by 100 squared. So if I divide this by 100 squared, so I'm going to have this divided by 100 squared. So I'm going to have my area as 2,3 square meters. So The area is given, the area that they want it in square meters, and I've done it in square centimeters because I can see there are centimeters here, because the longest route will be to change each and every one of that into meter, and then from there work it out here and get to this answer. But I've seen that I only have one which is in meters. I can change this one and then from there work out the answer and divide the answer at the end so that I can get that one in square meters. Boys and girls, this is very, 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 very crucial that we practice the question paper, the whole question paper, and see how many marks we get. And with these activities that I've done, these activities are always there in an exam. These examples are always there in an exams. You'll find such question. Go and practice this one so that then you are able to can pass on Monday. And good luck in your exam on Monday. Please make sure that you get 80 marks and above, 80 being the minimum mark that you need to get. Thank you so much.